Today we are taking some of the queries of students as given by them. Now the very first thing is this problem. This is related to checking correctness of formula. Checking correctness of formula. As I told you, okay, in checking correctness of formula, we have to just check about the dimensional formula of left hand side and dimensional formula of right hand side. Now, first of all, analyze the quantities here. Now, first quantity is, this is displacement in nth second. Okay, suppose a body is going from 0 to 10 second. Okay, in 10th second only. Okay, 7th second only, 6th second only. Okay, this is a situation of that type. Displacement in nth second. इसका जो dimensional formula बनेगा, that will be displacement in nth second. Displacement in nth second, तो यहाँ पे आएगा second. Okay, so this will be giving a rise to displacement in nth second, that is LT minus 1. This is your first term, displacement in nth second. Hope you have understood. Displacement in nth second. Now, second thing is initial velocity. Initial velocity will be velocity. Okay, and formula for velocity is LT minus 1. Okay, now the next thing is this particular thing. This is your acceleration. Okay, for acceleration we have formula. Acceleration is velocity over time. Okay, velocity is LT minus 1 over, तो ये आता है LT minus 2. Okay, now the next thing is this nth second, displacement in nth second ना, तो ये this is the nth second in which we are finding the displacement. Okay, so this is time. Nth second is time. Okay, so dimensional formula for this is T. Now you have to take left hand side and right hand side. Taking left hand side is S nth. Displacement in nth second. Already I told you, displacement in nth second, LT minus 1. So this is your left hand side. Now right hand side is U plus A by 2 N minus 1. Okay, now this is your initial velocity. Initial velocity is velocity LT minus 1 plus 1 by 2. 1 by 2 will not be, putting here anything. Acceleration is LT minus 2. Okay, then bracket 2, it will not be contributing anything. N corresponds to time. Minus 1 constant, so will not contribute anything. So right hand side which we are getting, that is LT minus 1 plus LT minus 1. So LT minus 1 plus LT minus 1 is LT minus 1. Okay, so right hand side is LT minus 1. What is dimensional formula for left hand side? Already we have calculated. Dimensional formula for left hand side is this. Okay, left hand side and right hand side both have same dimensional formula. Okay, left hand side and right hand side dimensional formulas are equal, therefore the formula is correct. This is the next problem. Find dimensional formula of K in this given relation, where this T is time period, L is length, G is acceleration due to gravity, and this M, this is mass, okay, and this G is universal gravitational constant. Okay, now let's have formulas of these individual quantities. Now very first is time period. Time period will have T. K के लिए we have to calculate. L is length. Length will be measured as L. Now G is acceleration due to gravity. Acceleration due to gravity. Basically this is acceleration, LT minus 2. M, mass, M, capital M. Another is universal gravitational constant, capital G. How this will be calculated? See here. Universal gravitational constant के लिए what we will be doing? F is equal to G m1 m2 over r square. Newton law of gravitation. Okay. So G, this implies G is equal to F r square over m1 m2. F m L T minus 2 r square, r length square, then mass into mass. Solving this all, we get m minus 1, L cube and T minus 2. This is formula for G now. Hope this is clear. Now placing these all values in the given relation. This one. Okay. Now to solve this particular thing in a better way, squaring both sides. Iska squaring both sides. Okay. T square, 4 pi square, K, this and this. Now take K on one side, rest all on other side. K is equal to M, this. Now placing dimensional formula for all the quantities, we will be getting dimensional formula for K. Now M is mass, G, acceleration due to gravity, is already we have calculated, M minus 1, L cube, T minus 2. Okay. G, and then T square, that is time square. 4 pi square, constant. Okay. L square, length square. G, acceleration due to gravity, LT minus 2. Solving this all, we will be getting dimensional formula for K. We get T square. This and this cancelling, this L cube, this cancelling, this T minus 2, the remaining term is T minus 2, T plus 2, T minus 2 going above will be T square. Okay, and we are getting K is equal to T square. If you want to write it in terms of mass, length and time, then you can write it like this: M0, L0 and T square. Hope this is clear. This is one more problem. The value of Stephen's constant is sigma is equal to 5.67 into 10 to the power minus 8 joule per second per meter square per Kelvin raised to 4. Find its value in CGS system. Okay, the value which is given, okay, that is given in SI, standard system, and we have to convert in new system. The system is CGS system. This is the situation. This problem is related to conversion of units. Now first of all, we have to see which quantity is to be converted. As given in question, the quantity is Stephen's constant. Okay, quantity is Stephen's constant. Stephen's constant. Now first of all, dimensional formula for Stephen's constant. This is a new quantity. Let's calculate that. Okay. Stephen's constant is E is equal to sigma T raised to the power 4. From this formula we can calculate the dimensional formula for Stephen's constant. Now what is E? No doubt this is energy. But this is not only energy. This is energy per second per unit area. Energy per second per unit area. Okay, I mean this will not be having only dimensional formula for energy. Dimensional formula will be energy per second per unit area. Sigma is our Stephen's constant. Okay, Stephen's constant. This is our temperature. Okay, now energy per second per unit area. Energy per second डिनोमिनेटर में, पर यूनिट एरिया भी डिनोमिनेटर में. तो dimensional formula for this will be energy will be ml square t minus 2 over second time area L square. Okay, solving this we will be getting m, then L square and L square cancelled, t when going in numerator will be giving, यहाँ पे 1 है तो it will be -1, and t minus 2 and -1 will be making t minus 3. Okay, now this is your energy per second per unit area. Now temperature will be giving you Kelvin K. Okay, now placing this all in given formula, energy per second per unit area is mt minus 3 is equal to sigma temperature raised to the power 4. Temperature mean Kelvin raised to the power 4. This implies sigma, that is Stephen's constant, has a dimensional formula mt minus 3. This will be going downside, k plus 4 downside, so when it will be going in numerator power will change, negate kar lega, k minus 4. So this is your Stephen constant's formula. Okay, one more thing you have learned. Okay, now conversion. Same way we will be leading with conversion. N1, number of repetitions for unit 1, is equal to number of repetitions for unit 2. Okay, now dimensional formula for Stephen's constant is this. Fine. Now writing or extrapolating this relation, N1 U1 unit 1 में mass in the first system raised to the power 1. Length is not there, length raised to 0. Okay, so we'll not be taking into account time in the first system raised to minus 3. Temperature, that is Kelvin temperature in the first system raised to minus 4 is equal to, okay, N2 in second system. Now mass in second system is M2 raised to 1. Then time in the second system raised to minus 3, and temperature, that is Kelvin, in the second system raised to minus 4. Okay, now placing all the values. Now once again, this is SI, this is in SI unit, okay, and this part is in CGS. Now N1, what's the value of N1? Okay, as I given you, that is 5.67 into 10 to the power minus 8. This is N1. This is your U1. N2 you have to calculate, or U2 is CGS. Fine. So let's take this. Now N1 is 5.67 into 10 to the power minus 8. This is your N1. U1 may first of all will be mass. Okay, mass SI, so kg raised to 1 time 1 second raised to minus 3 Kelvin, 1 Kelvin raised to minus 4 in SI. Now N2 we have to calculate mass in CGS because we are converting it to CGS, that is gram. 1 gram raised to 1 time remain in second, time has same thing, second in SI as well as CGS. So 1 second raised to minus 3 Kelvin. Okay, Kelvin, same temperature has the same thing for SI as well as CGS, Kelvin. Okay, 1 K raised to minus 4. Now N2 is equal to, this way we will be able to modify this relation. Now solving this will be remaining 5.67 into 10 to the power minus 8. Now 1 kg will be 1000 grams over 1 gram. Fine, raised to 1, rest all same, like this. Okay, second this. Now gram gone, second Kelvin. Here we are getting 1000 raised to the power 1, so it will be 1000. This is second and second gone, 1 raised to minus 3 will be 1. Kelvin gone, 1 raised to minus 4, that will be giving 1. And another thing which is turning up over here is 5.67 into 10 to the power minus 8. So solving this all, fine, this is minus 8, this is 10 to the power minus 3. So we are getting N2 is equal to 5.67 into, this is 10 to the power minus 5. 10 to the power minus 5, like this. Now answer for this will be N2 already we have, this is 5.67, this joule, this N2 already we have calculated. N2 will be 5.67 into 10 to the power minus 5. Now how you will be writing the unit? This is joule के correspondingly CGS में होता है अर्ग टाइम के लिए सेकंड ही होगा, पर सेकंड मीटर सेंटीमीटर per centimeter square, and Kelvin will remain as Kelvin raised to minus 4. This will be the answer. Okay. Another problem. When 1 meter, 1 kg and 1 minute are taken as fundamental units. This is a system which is defined this way. 1 meter, 1 kg and 1 minute are taken as fundamental units. The magnitude of force is 36 units. 36 units in this given system. Okay. What is the value of this force in CGS? Okay. From this given system, from this given undefined system, okay, in which the force has magnitude 36 unit, we have to convert the force in CGS system. Okay, this is an example of conversion of units. How to lead with this conversion now as given, force is measured as the quantity which is involved is force. First thing, dimensional formula for that is MLT minus 2. Force as measured is 36 units. In a system where length is measured as 1 meter, mass is measured as 1 kg kilograms, and time is measured as 1 minute. Okay, minute. And we are told to convert the force from this system to a new system, which is CGS. Okay, from this to CGS. Same way we will be leading, that is N1 U1 is equal to N2 U2. Fine. In the first system, N1, okay, N1 is given as 36 units. U1 force में mass single power, length and time -2. So writing, extrapolating this, N1, okay, unit 1 में mass in the first system raised to 1, length in the first system raised to 1, time in the first system raised to -2. Then N2, mass in the second system raised to 1, length in the second system raised to 1, and time in the second system raised to -2. Okay, now placing all the values. N1 is 36 units. 36. Now mass is measured as 1 kg. 1 kg raised to 1. Length is measured as 1 meter. 1 meter raised to 1. Time is measured as 1 minute raised to -2. Hope this is clear. Now the next thing is N2 we have to calculate, and this system is CGS. Mass in the CGS system is 1 gram raised to 1. Length 1 centimeter raised to 1. Time 1 second raised to -2. Hope it's clear. Now we have to calculate N2. So bringing this in denominator. Like this we will be getting. Now placing all the values and converting. N2 is 36 kg. Convert this into grams. 100 grams. Divide by 1 gram as existing in denominator raised to 1. 1 meter. 100 centimeter by 1 centimeter. 1 minute is 60 second over 1 second. This is main step. Okay, fine. जहाँ पे conversion आपको really okay ध्यान से करना पड़ेगा. तो ग्राम एंड ग्राम गॉन, सेंटीमीटर एंड सेंटीमीटर, सेकेंड एंड सेकेंड. तो N2 is equal to 36 into the 100. This is again 100 raised to 1. Okay, this is 60 raised to -2. 60 raised to -2. Now 36 100 का बन गया 10 to the power 4, और ये 60 को हम क्या कर रहे हैं, इन्वर्स कर देते हैं. 1/60 स्क्वायर. तो 60 into 60 ये बन गया 3600. Okay, so solving this all, we will have here by mistake we have written 100. So this is 1000 basically. So as this is 1000, this will also be 1000. Okay, and this will not be 10 to the power 4. This will be 10 to the power 5. And when cancelling all, we will be getting 10 to the power 3. And 2 is equal to 10 to the power 3. Okay, so how you will be able to write the answer? This 36 units in the given system is equal to 10 to the power 3 in CGS. Hope it's clear. One more problem. Check the correctness of the relation. H is equal to 2 sigma cos theta divided by r square dg, where h is height, Sigma is surface tension, theta is angle of contact, r is radius, d is density, and g is acceleration due to gravity. Now you have to check whether this formula is correct or not. This is the formula which is given. Okay. Now taking left hand side. Left hand side is height. So height will be measured in terms of length. L raised to the power 1 only. This is your left hand side. Now right hand side. Right hand side is 2. Okay. For 2 we will not be writing anything. Sigma, surface tension. Surface tension is force per unit length. Force per unit length mean M L T minus 2 divided by L. That is MT minus 2. MT minus 2. Okay. MT minus 2. So sigma is MT minus 2. Cos theta is dimensionless. Cos theta dimensionless. R square. Okay. This R square is length square. Radius will be measured in the form of length. Density. Density is mass per unit volume. That is ml minus 3. Okay. Density ml minus 3. Okay. Now G. Acceleration due to gravity. This is acceleration. LT minus 2. Okay. Now cancel karte hain. Cancelling this all, this is t minus 2, t minus 2 is cancelling here, L minus 3, and this is L square and L cube and L minus 3. This is equal to 1. Okay, so left hand side has formula L, and right hand side is dimensionless. Okay, left hand side has formula L and right hand side dimensionless. Okay, so as left hand side is not equal to right hand side, okay, formula is incorrect. Formula is incorrect. Just we have to check the validity of principle of homogeneity. Fine. Hope this is clear. The next situation as given is the frequency nu of an oscillating drop may depend upon radius r of the drop, density rho of the liquid, and surface tension S of the liquid. Deduce the formula dimensionally. Mean we have to derive formula C in terms of radius, density, and surface tension. We have to derive formula for frequency of oscillation of the drop in terms of radius of the drop, density of the liquid, and surface tension. The same way we will be proceeding. Equality, a constant from our side, radius raised to the power A, let density has raised to the power B, and surface tension raised to power C. Okay, now placing dimensional formula for all the quantities. Frequency is inverse of time period. Frequency 1 by t. So t minus 1. This is t minus 1. Mass length 0 raised to the power 0. Okay. K, that is constant. Radius is length raised to the power A. Density is mass per unit volume. So ml minus 3 raised to the power B. Then is surface tension. Surface tension, I told you, surface tension is force per unit length. That is mlt minus 2 over length. Mt minus 2. Mt minus 2 raised to the power C. It's okay. Now segregating time, mass, and length. K. So mass B, mass C. So when multiplying, powers will be added. Mass B plus C. Mass B plus C. Length. Length A, length 3B. Length A minus 3B. Powers will be added. Okay. Time. Time is minus 2C. Hope everything is considered. Let's check. Mass B, mass C, mass B plus C, length A, this A minus 3B. Okay, all taken into account. Now, mass power 0 this side, length power 0 this side. Now comparing mass, length and time. Comparing mass, length and time, we are getting B plus C equal to 0, A minus 3B is equal to 0, minus 2C is equal to minus 1 from 3. Okay. C is equal to 1 by 2. C is equal to 1 by 2. First value. Placing in 1. C is equal to 1 by 2. So B will be minus 1 by 2. B will be equal to minus 1 by 2. Now placing this value in equation 2 to find A. We are getting A is equal to 3 by 2. Now placing these all values in the main considered equation, that is this equation. Okay, fine. Now frequency is equal to K. Radius raised to the power A. Radius raised to the power A. A is 3 by 2. Fine. A is 3 by 2. Density raised to the power B. Minus 1 by 2. Mean denominator में ले जाओ और इसका positive power कर दो. Surface tension raised to the power C. Surface tension raised to the power C. Okay. Now this relation can be written as frequency is equal to K R cube raised to the power 1 by 2. Density denominator में आ गया, power 1 by 2 और surface tension numerator में ही रहा, power 1 by 2. जब देखो 1 by 2 सब, तो we can write this as frequency is equal to K outside under root, half power को under root में convert कर दिया. This is R cube S over density. So this is the final relation we are getting for frequency.